So let's continue from where we stopped. And the one who asked the question, I don't know whether your question is being answered or not. If it's not, you can still ask. We try to find a way to answer it. Is C online, or the one who asked the question initially?
Yes, I'm online.
Huh?
Yes.
So is your question being answered?
Yes.
Yeah. So the sign there is just to get rid of the X. That was the goal. So now that we know, we use both substitution and elimination method. And the solution is what? Where X should be, this is X coordinate, then Y coordinate. So the solution for that system of linear equation, we have what? X should be what? 2, and Y should be 3. So we use both substitution and elimination method to get these answers. Either method you use, you will have the same answer. It depends on your choice, personal choice. So now that we say that this is a unique solution, so meaning that this is the only combination whereby the system can be solved. So if we want to represent this through graph, the graphical representation, we can have this. You will see that, remember, we can even write the system again. The system was what? 2x 2x minus y equals to 1. Then we also have 3x plus 2y equals to 12. So this was the system. So the solution to this system is this. So let's look at it graphically. So this is the algebraic solution to the system of equation. Then let's look at the graphical solution. And when you talk about graphical solution, it's where these two lines, remember this equation is a line, and this equation is also a line, equation 2. So first, let's try to graph this 2x minus y equals to 1. Remember, to graph a linear equation, we talked about we have to find the intercept. And we have looked at this, how to find this intercept in our last class. So I'm not going to do it. I will just bring the numbers. So let's try to graph the first one. So when we looked at 2x minus y equals to 1, so we will look at the intercepts. So the intercept will be this: when x equals to 0, then we will have y should be 1. Here, when y is 0, then x is half. So you can confirm this. We have looked at how to find these intercepts. So these are the coordinates whereby the graph cut x and y axis. We have talked about this in our last class, if you could remember. So we will have this. So for the first graph, this is y intercept, and this is x intercept. So for let's do our let's even take by 2, 4, 6. The unit depends on you, the one doing the graph. So we can have here minus 2. I'm taking 2 units. Then 4. Then we have 6. Then here could be 1. Or let's take it 2 by 2 dimension, the same. 4, 6. Then it goes on up. So here also the same unit. We could have 2 minus 2 minus 4 minus 6, and it goes on. So here, when x equals to 0, let's look at this. when x equals to 0 here, someone asked us to put it there last class. When x equals to 0, then y equals to what? Minus 1. So we will have 1 around here. Let's assume minus 1 is here because this is 2. So we have it, then that is y-intercept. So when y equals to 0, x equals to half, which will be around here. So we will have a straight line. I'm sorry, drawing a graph with a mouse is very horrible, but let's assume this cut here. Okay, let's say it cuts here. So this will be the graph of 2x minus y equals to 1. So then we also look at here, this other one, the second equation. We have to find the x and the y intercept in order to be able to draw the graph on the plane. So we will realize that the intercepts are these ones, 0 and 6. So here, this is what? The y-intercept. So in the x-intercept, we will have what? 4 and 0. So this is x-intercept. So what x-intercept mean? When x equals to, sorry, when y equals to 0, what will be the value of x? So all what you need to do is to make here 0. So this will be 3x, and it goes like that. So here, we look at our intercepts. Y-intercept is what? 6 here, which is this one. So the x-intercept is this. So here, this thing is to come up to here. So here is where they intersect. So this is the solution. And this solution is nothing but x is 2 here. These 2 should have come here, and 3. But because of the graph, they are drawing it is difficult. So this is how the graph will look like. It will have a unique solution, which will be here, where the 2 graphs intersect. So that's why we call it unique solution. But with your with a graph or on a paper, you can draw this more accurate relative to what you are seeing here. So we have a unique solution. So when a system has a unique solution, so this is a line, which is the graph, the linear equation. So this one will be 3x plus 2y equals to 12. So the only point where these 2 graphs intersect is here. That is 2x equals to 2 and y equals to 3. So this is the solution to this system of equation. So this is a graphical solution, and this one that we got it through substitution or elimination method is the algebraic solution. So this is how we solve linear system of equation. So over time, we will see the real application of this in demand and supply analysis. We will also see it in production line, where you have to combine two or more goods to achieve certain profit targets. We will also see the application. But before we go to application, we need to understand the mathematical tool first. If you have any question relating to the first one, this system, unique solution, you can ask. Or if you have a comment or you know something, a better solution, you can bring it on board. We share. Any comment, question before we move forward? So everything is well understood. I'm talking to the class, yes, no response. All right, so we go on. So what?
How do you know that when x equals to minus 2, when x equals to minus 1, then y is 1? How do you know that?
Last class, where we looked at how to graph a linear equations. So to graph a linear equation, first thing that you should find is that y and x intercept. You know, what do we mean by y-intercept? You understand? Y-intercept is where the graph cross the y-axis when x equals to 0. We talked about this in last class. So if you can go back to last class, I will share the video with you and with some materials today. So I cannot go back and again and calculate, but this is it. Yeah, there is a way to calculate this 6, how we got this 6. It's not magic. How we got this 4 is not magic. It's just we are calculating. Here, this 6 is what is the y-intercept. This 4 is the x-intercept for this graph, that is 3x plus 2y. So for this graph, the intercepts are this one, -1 and half. So we looked at this last class, finding intercept for y and x for a linear equation. So if you go back to that, you will see how we solve it. So it's just not magic. I cannot go back to that again. It will take time and we don't have much time. But you can, take last class as a reference video and you will see how we calculate the y and x intercepts as well. Is that okay? Okay, so we moved to a system whereby there is no solution. Remember we said that the system, the solution, there could be a solution, there could be no solution. You understand? If there is a solution, the solution might be one unique solution like this one. Or we might have a solution, but we have many, many solutions. So for the first one that we look is a unique solution. And this unique solution is where x equals to 2 and y equals to 3. So let's look at a situation whereby there is no solution. That is 2, that the system has no solution. So you look at a situation whereby the linear system of equation, the solution doesn't exist. That is a system So what we are doing, we are trying to hone our tools or skill set, so that when we start doing some application, we will not have much problem with no solution. So normally, geometrically, when a system doesn't have a solution, you will have two parallel lines that will never meet. So we will see the graphical representation of such a situation. For example, let's say that this is a system. Let's say solve the system. So when they say solve the system, what it's trying to task you or ask you is to find a solution. Let's say that we have 2x minus y equals to 1. And then we also have 6x minus 3y equals to 12. So we have 1 here. This is the first equation. We have the second equation. This I will just go on and use only substitution. The elimination method, I will not do that again. I have shown you that in the first. You can do that. So first, let's assume that we are going to use a substitution method for this. So the elimination method, that can be an assignment for you. You just do it as an assignment without not submitting it. But it's important you do it. So we have a substitution method. So in the substitution method, what we need to do is we can take this first equation like before and make y the subject of the formula. So y can come here. This will give us 2x plus, this will be minus 1. So 1 will come here, the sign will change to minus. Y will come here, the sign will change to positive. So this is the same as y equals to 2x minus 1. So we assume that this is our third equation. So we have 1, 2, then third. So what we will do, we will substitute this third equation into the second equation. That's why we call it substitution method, the name. This is how the name came about. So our third equation is what? 6x minus 3y equals to 12. So all what we need to do, we substitute this here. And when we do equivalently, we will have 6x minus 3 times y, and we know that y is what? It's 2x minus 1, then equals to 12. So we will have something like this, 6x minus 6x. How did we get 6x? This is 3 times 2, 6, the minus and the x. So this will give us what? Plus 3, then equals to 12. So remember, we can collect the like terms. 6x and 6x, they are like terms. 12 and 3, they are like terms because they are constant. So 6x minus 6x, that will give us what? 0. So then we will have 12. This will come here, it will be minus 3. So at the end of the day, we'll have 0 equals to 9. So I will stop here. Then I ask the class, what do you think of this expression? Who will volunteer? 0 equals to 9. What do you think of this expression?
Sorry, sir. Which one?
Are you not seeing it? 0 equals to 9. This here. Here.
Yes.
Well, it's a unique solution, sir.
Sorry?
It is a unique solution. We try to say at 0, 100%.
So this is
I don't know how
undefined.
to even explain
It's
that.
what? Someone said undefined.
It's undefined.
Now in mathematics, undefined happens when you have a number. Let's say k is any number divided by 0. This is what you call undefined in mathematics.
There's no variable here.
Yeah, there is no variable. Good observation. And what again? No variable. And what again? The most important thing, it says that 0 equals to 9. What do you make of that? 0 equals to 9. Is that true?
No.
This is not
a number
true.
cannot be equal to a number.
Correct.
Exactly. 9 is greater than 0. Or 0 is less than.
If you point this in a calculator, it will give you syntax error.
Exactly. You will have something like that. So that anytime you do substitution method and you come to up to this point, the only conclusion is that the system doesn't have a solution. And by system, I guess everyone knows what I mean by system. Is this equation, that is this two linear equation. There is no solution. There is no point whereby the two lines meet. You know, we have here a unique solution. They meet here. But for a case, this case, there is no solution because the lines are parallel. They will never meet. No matter how much you travel from Banjul to Brikama, the two lines will never meet. So if you see such a statement, you are trying to solve a system of equation and you come across this kind of statement, just stop and save your time. One good observation, you will not see any variable. There will be two numbers and you will have an equation, but the equation will not be true. Remember, we said equation because of the equals to sign. So you will have an equation that is not true. So this is not true because 9 is greater than 0. So if you are trying to solve a system of equation whereby you come across this kind of equation which is not true, just stop and save your energy and you conclude that the system has no solution. So let's go and look at this graphically and see how they will. You will see that geometrically, when you are trying to solve a system of equation, the two equations, that is this one and this one, they will intersect at some point. But a system that doesn't have a solution, they will never intersect. You will have something like this. You will have an equation that is running like this, one equation, another equation that is running like this. No matter how much distance you travel, they will just be running, but they will never intersect. So how do you know that expressions like this will tell you that this system is not having a solution? So let's try to visualize this true graph. Well, let's look at the graphical solution to it, how it will look alike. So once you have this, just stop and say the system doesn't have a solution. Remember when we are trying to solve the first one, we were able to have a nice, whereby you have y equals to 2, remember, right? But we don't have such a thing here. We have an equation that is not even, is mathematically wrong. 0 is not equals to 9. So let's look at the graph of it and see how it will look alike. So we have a graph here for a system that doesn't have a solution. We have the y-axis. Then we have the x-axis. So remember, first, when you are graphing linear equation, what do we have to remember is the intercepts. It's the intercepts. So we have a system here, and I'm writing the system again, which is 2x minus y equals to 1. Then the second equation, which is linear, two of the equations are both linear, 6x minus 3y equals to 12. So we have to graph this and we have to graph this. And to graph them first, we have to ask ourselves, what are their intercepts? The x and the y intercepts for each of the equations. So let's start with this. I will just give you the intercept. I will not solve it. We have done it in the last class. So here, 2x minus y equals to 1. So the y-intercept, will be, that is when x equals to 0, y will be how much? Y will be minus 1. So I'm not just bringing this from the sky. There is a way we use to calculate. Go back to your last lecture notes, or I will share the videos with you. But here, when y equals to 0, then x equals to what? Half. So these are the intercepts. So this is y-intercepts, and this is x-intercept for this equation. So we can draw this graph, the first linear equation, the graph with a line. So what we can do, we can take this one. It's raining here. I hope you guys are hearing me clearly. We have 4, 5. And when we are talking to a third party, please, let's mute our microphone, please. We are disturbing the class, please.
Sorry.
So we have 2. Then we have 3. Then we have 4. So here we will have something like -1 for x-axis on the negative side, that is to the left. -2, -3, then -4. So here we'll have 1, we have 2, we have 3, and we go on 4. So for the first equation, remember this is our first equation. We have the intercepts already. So when x equals to 0, y is what? -1. So here is our 0. So here we have this. That is the, sorry, this should be here. Should be here. When x is 0 here, then y is -1. We have it here. So when y is 0, x is half. So we will have half around here. Sorry for my graphs. I have terrible way of writing especially here. So this one is better. We have this. So this line you are seeing is nothing but the graph of 2x minus y equals to 1. So we will do the same thing for the second equation. We look for the intercepts. And the second equation is what? 6x minus 3y equals to 12. So here, the y-intercept for this one is when x is 0, then y is what? -4. And for y, this is y-intercept. So for x-intercept, when y is 0, then x is what? X is 2. So we'll do these intercepts. So here, when x is 0, y is what? -4, which is here. So this is our y-axis. So when y is 0, then x is what? 2. We have this. So you will have a line like this. Sorry. So this will cross something like here. So we'll have here 6x minus 3y equals to 12. So you see these graphs, they, in mathematics, we call them, or in geometry, we call them parallel lines. They will never intersect. So you will see that there is no intersection point here. No matter how much, even we extend this, we go as far as possible, they will never intersect. And because of that, that's why you have this weird equation here, where you have 0 equals to 9. So this is the visualization of a solution, of a system of equation whereby the solution, there is no solution. So there is no solution for this system. This system, there is no solution. There is no solution. So first we look at where there is a solution, unique solution. The second one, there is no solution. And the third one that we will look at is where we have a solution, but the solutions are many. We have infinitely many solutions. So that will be the third case for linear systems of equation. But before we move to infinitely many solutions for a system of linear equation, if you have a question, a comment, or you want to add something to this, then the floor is open for you. If you have a question, please go on and ask. Let's make, if you have any doubts, let's seek for clarification, please.
Mr. Ture?
Yes.
I didn't attend the last class, so I don't know how am I going to get the video.
Okay, to get the videos, normally what I do, I have a YouTube channel. I upload these videos there. I was so busy last week, I couldn't do it, but probably before the day ends today, I will do it, and I will share the links on the WhatsApp, the group, the class WhatsApp group. That's one way of getting the lecture. The second way is I think you will have some friends. You can get the notes from them as well. So, so these are the two ways you can get the last class videos or lectures.
All right, thank you.
You're welcome. So if you have a question, comment, or anything related to the class, you can bring it on board. Let's share. Mathematics is, is unique, but we have many ways of solving one problem. So someone might know another quick way that you can share with the class. Let's take here as a knowledge sharing session. We can share what we know with the class. So if you have questions, please, any kind of question, please bring it. Let's clear the doubts before you enter with them in an exam. So let's clear them here. The floor is open before we move to the third scenario, whereby we have many solutions to a system of linear equation. If you have any question, please don't hesitate, bring them on board. We talked about it, we looked at it as a class.
And Mr. Ture,
Yes.
the second equation that we just solved that has no solution,
Yes.
in the event that it came to the exam, the question is there and then you solve it and you see that there is no solution.
Yes.
Do you just go ahead and write that there's no solution and then leave it there, that, or you have to show the graphic there?
Yeah, the question will
You have to draw the graph.
the question will direct you whether there is a need for graph or not.
Okay.
The
In
question-
the event that there's no graph, you will leave it there and then comment that
in the
there's no
event
solution.
that there is the question is silent, whether you should show the graph or not, it's left to you. But I, as a student, I always want to go extra mile to tell the lecturer or the teacher that I know what I'm doing. That can come as a bonus, you understand? So, but normally the question will direct you whether you should show, you know, I can ask you show the graphical solution, which is this one. This is the graphical solution. So here, you can stop here, which is algebraic solution. But this graph is the graphical, it's more of a geometry. So I can actually show the geometric solution or graphical solution, which is this. So if I am silent about it, then it's left to you to go and do extra, if you know, extra work, you know, attract extra reward. So it depends on you.
All right, thank you.
Okay, if there is no other question, we can look at the third scenario whereby we have a linear system of equation or simultaneous system of equation, but there is many solutions that exist for it. So let me ask this to the class. I like this class to be interactive. That's why I don't like these online classes. You know, you cannot see faces to ask them. So in the third scenario, let's make this interactive. So the third scenario, a system, so when you hear system, we are just talking about simultaneous equations, a system of equations or simultaneous equations with so when we said infinitely, what do you understand that in mathematics? Meaning that there is no end. So we have a lot of solutions, infinitely many solutions.
Yes.
So, you know, remember, I always, in the start of the course, I asked you how can we solve a linear system of equation? We talked about one way is through algebra or algebraic. Another way is through what? Graph or geometry. That is the graph. So the question is through algebra. You know, remember that here we said 0 equals to 9. We'll have such an expression. So this is algebraic solution. But in a system whereby we have infinitely many solutions, like this one, we have infinitely many solutions. How will the algebra look like? Like equals to. What will be the equals to here and here? And here, what will the graph look like? So is there anyone who wants to give a shot and try? I hope the question is well understood first before we even go to the answers.
No, sir.
What I'm trying to say, like to solve a linear system of equation, like for example, let's look at this. We have this system like 2x, this is 2x minus y equals to 1. Then we have 6x minus 3y equals to 3. So this is the first equation, right? And this is the second equation. So this is our system of linear equation. And if you solve this, as I did before this class, you will find out that the solution is infinitely many solutions. Remember, in unique solution, we have 2 and 3 is the only solution. But in a system, when you have a unique many solution, infinitely many solution, You can have this, you have orders, it goes up to, you cannot count them. That's why we call infinitely. So to solve this, we can use algebra, that is substitution or elimination, or we can use the graph. So like here, if you use algebra, it gives you this weird equality, 0 equals to 9. So in a situation like infinitely many solution, what you will have, it will give you a expression like this, 0 equals to 0. If we solve this, we'll have something like 0 equals to 0. So when you solve this kind of a system of equation and you end up having 0 equals to 0, know that the solution is what? Infinitely many solution. I hope that is clear.
Yes, sir.
Exactly. So that is the algebra solution. So what do we use here? Substitution or elimination. So when you use substitution or elimination, you will have an expression whereby you have 0 here, you have 0 here. So if that happens to you while you are solving a system of equation, then you can confidentially say that the system, it has infinitely many solutions. But how would the graph look like? In the graph, you will only have one line. Remember here we have 2 lines. And in the Unix solution, we have 2 lines. But when the solution is infinitely many solutions, you will only have only 1 line. So for this, if we go on to graph this, we'll have something like this. So this graph, it represents both 2x minus y equals to 1. It also represents what? 6x minus 3y equals to 3. So it is telling you that this equation 1 and equation 2, they're all the same. So how do we know that? If we divide this by 3, we will have nothing but equation 1. So you will have 2x, here is 2x minus y equals to 1. So both equation 1 and equation 2, they are the same thing. So it is telling you equation 1 is equivalent to equation 2. In fact, equation 1 is a factor of equation 2. But we don't need to go up into this too much details. We are not doing mathematics major. But what you need to understand, once you solve it, this system, either substitution or elimination, and you have a equality whereby 0 equals to 0, then you can conclude and you have that the system has infinitely many solutions. So whenever you try to solve a linear system of equation and you have this kind of expression, 0 equals to 0, then you can say infinitely many solutions. But the graphical representation, you will only have 1 line. And that 1 line, it represents both equations, that is equation 1 and equation 2. So let's go on and try to solve this and see what will happen. I hope the message that I'm sending across is well received.
It's breaking. Some of the things I'm getting.
Sorry?
It's because of the rain. Some of the things I'm getting it, some of the things I'm not getting it.
Yeah, that's a problem. Even when you speak, I'm not getting you very well. I think it's breaking, but we will try to solve this also and see. So is everyone getting me clear, or is the same for everyone? My voice is breaking.
Yes.
No, let's solve this and we stop and stop here for today.
I think it's the rain too.
I'm not getting you either. So how is it now? Are you guys getting me very well?
Yes,
Yes, sir.
Okay. So the third situation.